Well, let's do some real problems. I wrote it. Let's do some level 5 of 10. We're not going balls to the wall yet. We'll keep it mid range, right? A little 5 out of 10 level. All right, let's jump into it. Have you ever seen this before? I'm curious if you know your reciprocal function. I will continue to beat this dead horse till you know this shit. 1 over x, that's what it looks like, huh? There it goes. That's the basic. Notice there's no numbers really written in here except for 0. And we know that the limit as x tends towards positive infinity of that function goes to that height 0. The limit as x tends towards negative infinity of that function also goes towards 0. The height. When we say 0, this 0 is the height. Y equals 0. All right. Moving forward. Moving forward. Let's do some. Let's do some problems. Have I really beat that horse enough? So let's go. Limit as x goes to infinity. Let's do an interesting one. 6x squared plus 5x minus 1 all over 5x squared minus 11. Okay. The answer is 6/5. The answer is 6/5. There's nothing to it. But I might ask you to show your steps. And it's cool to know the answer from algebra, but it's another thing to be able to show it. So when your homework, shit, you don't have to show anything, you just write down the answer. Why? Because what's the degree of the top? 2. Degree of the bottom's 2. Which means all you need to look at is 6x squared over 5x squared to find out where its end behavior, where the x values get larger and larger. So this is clearly equal to 6 over 5. But how we attack it and how we algebraically manipulate it is a whole different story. So if you're just stoked to know the answer, and you think you can move on by looking at these, I'll bet I can get you. So we need to learn how to do these tactics. Because we might be doing this inside of other functions and trying to figure out where stuff's going, and it can get wonky. So just keep in mind, the answer is 6/5. So all we want to do is look. Step 1, just ask ourselves. Once we have it the same degree top and bottom, we think, whatever that degree of the bottom, this will work for all of them, actually. If you just take the degree of the bottom, that's x squared. Take that degree and do this with it. Whatever it is, it's 1 over x to that degree. And we're going to multiply top and bottom by it. And it may seem super crazy, but we're multiplying by 1 right now. This is all calculus. We multiply by 1. It's fancy ones that we get better and better and better at. But this game works the same pretty much every time. So now this piece needs to come in and hit here, here, and here, along with this one coming through and hitting here, and here. It's just going to become, the x squared is just going to become the denominator of all that stuff. So we get the limit as x tends towards infinity, and I'm just going to write it 6x squared plus 5x minus 1 all over 5x squared minus 11. And like from the last video I showed you, these x squares, it's just going to become the denominators of all the terms. And then we can play that little game. We can go back to the limit as x tends towards infinity of any constant over an x to a positive exponent equaling 0. That's going to help us out. So let's see if we can't clean some shit up. Let's get rid of these x squareds on these two, huh? That cleans up. That's now independent, does not have any x value. So we don't give a shit where x is tending towards. Up top, that's a 6, right? Because we lost these x squareds. The next one, we have 5x over x squared. That's 5 over x. Oh, there's still an x left in the denominator. That shit's going to 0. The negative 1 over x squared, that shit's going to 0. All right, and then we go down here and we're like 5x squared over x squared. That's just 5. Minus 11 over x squared. Well, shit, there's an x down at the bottom. That shit's going to 0. So we go 0, 0, 0. And this isn't just me. This is common. So don't think that I'm just letting you do something. And you don't have to write this step. Just showing you that there's nothing left. There's no more x's left. It's just a number. And remember, when it's just a constant inside there, that's your answer. It goes to 6/5. There's your game. That's how it starts. Well, let's do a stupid one. Okay? Usually a teacher doesn't say let's do a stupid one. This is a level Level 2. Let's go level 2. I don't like the problem. It's silly. 5x squared minus 1 over x minus 2. These to state the frickin' answer. I don't need you really doing anything. The degree is larger than the bottom. Since it's all going to positive infinity, the answer is infinity. It's just freaking infinity. Come on, dude. Come on, I don't even want to really talk about these cases. The only real interesting piece of these cases would be something like this. I wonder if I could get you. Let's do this one. Let's take it to negative infinity. Now what's the answer? What's our answer here? Could you tell? Is it going to be negative infinity? Is it going to be positive infinity? Which one's it going to be? Well, since what's up top would be always positive, right? Squaring would always be positive. And what's down below would always be negative. This would go to negative infinity. And let me show you a counterexample. Or not a counterexample, but another problem that goes along this line. Let's take this one to negative infinity, but now let's make it 5x to the 4th minus 1 over x squared minus 2. So notice I created two even powers, right? Two even degrees, where everything turns positive. Hence, you're going to have a positive over a positive. So what's going to be our answer? Yeah, you guessed it. Boom, infinity. Now let me show you once how you do it. I don't care for you to ever. I'll never give you a problem like this. Maybe your homework might, but I would never give you a degree larger up top and down below and ask you to do anything with this. That should be a good tricky little problem. Let's go show how we would have tackled number 2 here. So the limit is x tends towards infinity of 5x squared minus 1 all over x minus 2. So we just look at what's the degree of the bottom? It's 1. So we're going to multiply top and bottom by 1 over x. Whatever the degree of the bottom is, just bring that shit in. So I'm going to quickly run through because this is silly. And I don't need you to do it. And that's 5x squared minus the 1 over x minus the 2. And then you just bring those x's in. It ensures that you're never going to get a 0 in your denominator. So that leaves us with what? 5x minus 1 over x all over 1 minus 2 over x. That goes to 0. That goes to 0. So the only thing you're left with here is the limit as x tends towards infinity of 5x. Well, shit, 5 times infinity? Pretty freaking sure that's infinity. So, boo! I don't like that method. You can just state the answer. The degree is larger up top than it is down below. You can just state the answer, but you must be careful. You better check if this thing's negative. What's the degrees of your, what's the degrees? Because that's going to make a lot of difference. Okay, moving on. I don't like talking about those too much. Let's do another. What's a cool one we can play with? Let's do this. The limit is x tends towards negative infinity of 5 minus 4x all over 3x plus 1. Do you think you got the answer? Do you think you can look at that one and be sure that you have the answer? Is it negative 4/3? Is it positive 4/3? Is it 4/3? Let's go find out. The degree of the top is 1, the degree of the bottom is 1, but we only give a shit about the degree of the bottom, so we just go 1 over x, 1 over x. We bring it in. Look how this game works the same way every time. We're not going to trip about that negative infinity because we're just going to let the work follow. And now we bring that x and we just put it underneath. Oops, that's a different one. That's a pink, not red. And then let's reduce this stuff down and see what the heck happens. All right, limit is x tends to negative infinity, and we got 5 over x minus 4 all over 3 plus 1 over x. Oh, wait a second. Does it matter if x is going to negative infinity when we have this? Did you get a different thing? Did something else pop out when you did this? Did you get something else besides 0? Did you get something? No, it's still freaking 0. It doesn't matter whether you're going to positive or negative. It doesn't matter if that's a 5 up there or negative 5. It makes no freaking difference. That's just a constant. That's a constant. 0 times a constant? That's freaking 0. What's up, dude? That's the trick to the squeeze theorem, by the way. go through it. And I misspoke on the squeeze term. It's not that one. It's the other one. Drawing a blank. So what's left? That limit is x tends towards negative infinity. Again, you do not need to show this step. What's left over? Negative 4 over 3. So the limit is x tends towards negative infinity of a constant is just equal to that constant. And we got negative 4/3. All right, fun shit. I think I'm gonna break these things up into a few more. So I'll do the weird root tricks, and then I'll do a couple of tougher ones. I'll break this into a few. I'll see you in the next.